Okay, welcome back. Thanks for joining. In this short refresher video, I'm going to look at a couple different examples on simply simplifying or using operations with radicals. Okay, so first and foremost, when we're talking about a radical, we are talking not only about this yummy stuff on the inside, but we are also talking about what's going on here in what's called the index. Now, this little index, or this part right here, if there's a little number that shows up, that is telling you the power of the radical. When you don't see a number there, we assume that it's a 2. Now, when we write square roots, most of the time we don't write the 2 here, okay? But you need to realize that any little number that shows up inside this little check mark or V part of the radical stands for the index of this radical. Now, what does this index tell you? Well, when we're talking specifically about this little number, this is telling you the number of identical terms in each group that can be pulled out. So what does that mean? Well, let me show you. First and foremost, I can break my radical down into individual pieces. So let's go ahead and let's start with just the number, square root of 24. So when we are talking about the number of terms, identical terms that can be pulled out, we are talking about taking your 24 and say breaking it down. So one thing that you can do is you can break it down and say, okay, 24 can break down into 4 times 6, and what I know is I know that 4 can break down into 2 and 2. Now if you look at it, I need identical terms, and in this case I need 2 of them. So I have them right here. I've got 2 identical terms, so that means this little part is a group. I have 2 values in it, they're the same, the number is 2, so that is what gets pulled out. Now when we look at the 6, your 6 can break down into 2 and 3, but notice these are different values. So therefore we can't do anything with it, we can't pull anything out, so the 6 remains under the radical. So what this means is that 24 is actually going to reduce down to 2 square roots of 6. Now we're going to leave that alone for a minute because we still have the rest of the radical to do. So I can do this again. I can take my next one. So we have x cubed. And again, I can break it down. And so here, I know that the first thing I can do is I can break this down by removing an x, so this becomes x and x squared. Again, these are 2 different terms, so now I can break x squared down again into x and x. And notice here I have a group of 2 identical terms, so the x pulls out, but notice I still have an x left over, so this is going to become x square root of x. Again, I can do it with y to the 4th. So when I break down y to the 4th, I can do it a couple of ways. First, I know that it can break down into y squared, and if you look, that is a group of 2 identical terms. Nothing is left over, so this just simply becomes y squared. Okay. Or another way that I could have broken it down is I had the square root of y to the 4th. I know that it can break down as y and y to the 3rd. I know that this can break down into y and y to the second. So if you look, I have a group of 2 identical terms, but then y to the second can break down again into y and y. So I have another group of 2 identical terms. Okay? Notice in each case I'd pull them out, which ends up with y squared. So whether you immediately broke it down or you broke it all the way down to the base is fine. Just remember you're making groups of 2. Now the last one we have to do is z to the 5th. So here we're going to do the square root of z to the 5th, and we're going to do it in the same way. So with this we can pull out a z and leaves behind z to the 4th, and then we know that this is going to break down into z squared and z squared, which is a group of 2. Therefore, what pulls out is my z squared, and what's left behind is z. So what do we do with all of this? Well, we have to essentially put it all together. So we had 2 square roots of 6, x square root of x, y squared, and z squared square root of z. So the rule that we use is generally this. So when we're talking about rules, this is what we have. Outside stays on the outside, and under the radical stays inside. So what exactly does that mean? Well, it means everything that is outside the radical gets combined first. So I have a 2. So I've got 2. I have x. I have y squared. I have z squared. Now I have my radical. I've got a 6. I have an x. I have a z. And this is your most simplified radical. Alright, let's look at another one, slightly different. So here I am multiplying 2 binomials together. So when we do this, the method to use is FOIL. So FOIL again means first, outer, inner, last. So I have my first. So this is going to be 2 square roots of 3 times 3 square roots of 3. So 2 square roots of 3 times 3 square roots of 3. This is first. I need to add that to my outer. So this is going to be 2 square roots of 3 and negative 2. So I'm going to have 2 square roots of 3 times negative 2. This was outer. Now I have to add it to inner, which is going to be 1 times the square root of 3. And I have to add it to my last, which is going to be 1 times negative 2. So that's FOIL, first, outer, inner, last. So with that, we have 2 times 3, which is going to be 6, and then I have the square root 3 times 3, which is 9. I have 2 times negative 2, which is going to be a negative 4 square root of 3. I have 1 times 3, so this is plus 3 square root of 3. And then I have 1 times negative 2, which is a negative 2. So now we just simply have to reduce. The square root of 9 is 3, so this is really going to be 18. Negative 4 plus 3 is going to give you a negative square root of 3, and then I have minus 2. I need to combine my terms, and so here we're going to end up with 16 minus the square root of 3. And this was the answer we were looking for. Alright, let's try another one. Here again we need to simplify, but I want you to notice we now have a 4. So what this says is we now need to make groups of 4 identical terms. So again, I can break them individually, so I can start with the 4th root of 81. And just like before, you could break it down. So I know 81 can break down into 9 times 9, but if I look, this is only a group of 2, I need a group of 4. So I gotta go again. 9 breaks into 3 times 3, and again, 3 times 3. And notice here, I now have a group, and they're 1, 2, 3, 4 terms, all of them are 3's. So what pulls out here is gonna be the 3. I then have the 4th root of x to the 24th. So the way that you're going to do your powers is you are going to look at them in terms of a fraction. So here what we're looking at is we are looking at x to the 24 over 4. So what you want to ask yourself is, does this fraction reduce down? And the answer is yes, it does. 4 can go into 24 6 times, which means that this really becomes x to the 6th. Now I have the 4th root of y to the 12th, and again we're going to do the same thing. Y to the 12 over 4, and we ask ourselves, does this reduce down nicely? And it does. This is going to become y to the 3rd. Last, I have the 4th root of z to the 5th. Again, we're going to look at z to the 5 over 4. And does this break down? Well, this answer is no. So this means that we now have to siphon off. So you're going to pull off one z, and you're going to leave behind z to the 4th. And again, we're going to look at, does this divide by 4? Well, it does. This ends up being z to the 1st. And so this pulls out, and this pulls out. So again, what we're left with is 3 x to the 6th, y to the 3rd, z, and then we have the 4th root of z. And this would be your simplified form. Alright. Alright, the last example we have here is we're going to simplify this radical fraction. So we like to call them rationals, glorified rationals. And so here, what you have to do whenever you have a radical in the denominator is you have to do what's called multiply by the conjugate. Conjugate simply means opposite operation. So here we have the square root of 5 minus 3. So your conjugate is going to be the square root of 5 plus 3. So what that means is that we have to take our rational and multiply both top and bottom by that conjugate term. Now when I do it, I like to draw myself the big old division line, and I like to multiply the bottom terms first. The reason for that is because the radical should completely disappear. If it doesn't disappear, then the chances are what you've done is you have multiplied by the wrong conjugate, and therefore you need to stop and redo your problem. Okay, so it's a good check so that you don't have to do extra work. So we're going to start with the bottom, and you have to FOIL. So again, this is going to be first. So you're going to have the square root of 5 times 5, which is 25. And then you have outer, so plus 3 square roots of 5. Then you have inner, minus 3 square roots of 5. Then you have last. Negative 3 times 3 is a negative 9. Now what you're looking for is that this middle term here completely disappears. So 3 square roots of 5 minus 3 square roots of 5, this part goes away. So I already instinctively know I've done it correctly, so we can go ahead and multiply the top. So again, we're going to have the square root of 5 times 5, which is 25. Then we need to do our outers, so plus 3 square roots of 5. Do your inners, so plus the square root of 5, and do your last, plus 3. Now we can go ahead and simplify. So across the top, the square root of 25 is 5. So this is going to be 5 plus 3 plus 1 makes it 4 square roots of 5 plus my 3. And then to the bottom, square root of 5 or 25 is 5. So this becomes 5 minus 9. And notice all of my radicals have disappeared in the bottom. Therefore, I know I'm on the right track. 5 plus 3 is 8, so this becomes 8 plus 4 square roots of 5 all over, and 5 minus 9 is a negative 4. Now you need to simplify. 8 over negative 4 is going to become negative 2. 4 over negative 4 becomes a negative 1 square root of 5 left over. And here is your simplified result. So if you have any questions, please let me know. Otherwise, enjoy your review, have fun with your math, and I will see you next time.